Hello everyone. Today I want to share some ideas about using pre-training model to accomplish face merging, just as what I write down in the PPT. And this idea is come from, today's a trend that a lot of face recognition problem, such like face facial image acquisition process uncertainty and diversity face pattern like bright glasses, hair, and so much things. It's sometimes hard to recognize those things, and also the face plastic pattern, plastic pattern, face plastic deformation of uncertainty, such as facial expressions, and also comprehensive knowledge of the field evolved, such as psychology, medicine, pattern recognition, image processing, a lot of things. And in my work, I want to take a look at the technique of uh, face recognition and corresponding face changing, aligning, coloring, and masking, things like that. And there are four steps in my article. The first one is detecting a face tag. In detail, is extracting all the facial marks from the original image, then extract two facial landmarks of extract facial landmarks from two images and then combine those facial landmarks. And also the second step is that once we get all the facial marks, you know one of the image maybe a little bit slide into that direction and another maybe slide into this direction, so we need to do some rotate things to make them slide into the same direction. And also their scale maybe not the same, maybe you need to scale down or scale scale down or scale up the one of the image in order to make them merge into one. And also the third step of our project is to adjust the color of two images, you know especially those edge part. In the edge part, there may be some overlap or discontinuity, so we need to do some coloring correction things. And also once we do those three steps, the final step is to merge them into the same picture. Okay, let's start from my PowerPoint. Okay, as you can hear, is the four steps of merging two pictures into one. The first one is extract facial landmarks, and then second is aligning face with prosecutes analysis. And third one is coloring, correcting the second image. And the fourth one is blending features from the second image onto the first. So let's take a look at the first part. As you can see from the picture, this one is the original picture, and the right one is the visual landmark that we extract from this picture. Also, the we had two pictures in total, in order to do the face changing things. But for here, I just want to show one of them because the theory is the same. Okay. Okay, after we do the facial detecting things, we need to do some rotation, scaling, and converting things. Oh, sorry, I forgot to mention that in order to do our facial detecting things, we need to have a predictor and detector. And detector is to detect the facial marks and mark them. And the predictor is based on those detector results, to make a predict about which part is your face. And our predictor is using a predictor from DLlib. It's an open source. It's an open source laboratory code, so I just use it. Well, the second part is to rotate or scaling and converting the second image. Okay, as you can see from the PowerPoint, there are two pictures in total. Once we target those two pictures, their sliding angles maybe not the same. Then we need to do some, rotate things. Such like you can see from our code, where is the rotate? As you can see, here is the step 2. Yeah, here we go. Here's the procedure to do the rotate or scaling things. And after using those code, our image could, in some extent, to do a good preparation for our merging work. And then come to our third part is to color correcting the second image. As you can see, the image, the color in the two image, especially the facial add part, maybe some cancel discontinuity. So we need to do some work to fix that. And what we do is by, because we first identify the issue. The issue is that difference in skin tone and lightening between the two images is causing a discontinuity around the edges of the overlaid region. So let's try to correct it. And our code to solve it is by just a second. It's by using a color correct code like that to make them more continuity. Like you can see here, our function is correct color image, and the input is image 1 and image 2 and all the facial marks from the image 1. Okay, here's our third step. And after the third step, there's a fairly clear solution to the problem, and a appropriate size Gaussian kernel is key. Too small or and facial features from the first image will show up in the second. Too large and kernel strays outside the face area of the pixels being overlaid, and the distortion occurs. Here, a kernel of 0.6 times the pupillarity distance is used in this work. Well, then come to our final work. Is to blending features from the second image onto the first. In this step, a mask is used to select which parts of image 2 and which parts of image 1 should be shown in the final image. And here's our code for doing that. As you can see here, let's make sure. Okay, so you can see step 4 is right here. And next, I'll do some code breakdown works to make it more clear. A rotating get face mask is defined to generate a mask, the right square for an image, and landmark matrix is just two canvas polygons in white. One surrounding the eye area and one surrounding the nose and mouth area. It then features the edge of the mask and outward by 11 pixels. Then the feature helps hide any remaining discontinuity. Such a face mask is generated from both images. The mask for the second is transformed into one correlating space using the same transformation as in step 2. The mask then contribute into one by taking an element once. Mask mod combining both masks ensure that features from image 1 are covered up and that features from image 2 show through. Finally, we got our pictures. As you can see from from the PPT, here's our two original pictures, and then it's the final result. And also the performance evaluation of existing approach. The result seems good enough to perfectly merge two faces, but once we take a further look, it seems not so good. Although we did a lot of things to deal with the ad problem, the discontinuity in terms of color or angles, things like that. So one of the ways to improve it is maybe by using different predictors. Our predictor is just using the predictor from the DLlib. It's maybe a raw predictor, and also the detector is also a quite normal. It's a quite common detector. Maybe in the future we can using other predictor or detectors to do our work. Maybe it could make some difference. Well, conclusion part. It's a good experiment and may apply to many different areas in this world, such like criminal identification, things like that. I've seen it from one of the movies, so it's a good work. Thank you.